As David Deutsch has observed, it wasn't just that people in the 1800s weren't able to predict the possibility of nuclear holocaust in the 20th century because it's an intractably complex problem, but rather they couldn't even conceive of what nuclear weapons were because nuclear physics was entirely unknown then. So people today making predictions about what disaster will or will not befall people in the coming century are in the same place as the brightest minds of the early Enlightenment were with respect to us today. They simply cannot conceive of what knowledge we would have. They, the people of the early Enlightenment, geniuses though they were, could not conceive of what knowledge we would have now. So any prediction they tried to make back then about what the world would be like now was based on the physics and science and philosophy of the 17th, 18th and 19th centuries, none of which even mention, for example, nuclear fission and fusion. What will we discover this century to completely change the calculus of our modern day prophets? But besides, knowledge is not only about predictions anyway, as we have said. That's the rare exception. The whole way of framing our situation with respect to knowledge as being merely an instrument for predicting what will happen in the future completely misses the point. Better theories explain more about what really exists. From general relativity, we get curved spacetime, we get black holes and gravitational waves, we get an expanding universe. None of these things are at all even mentioned under Newtonian gravity. Better theories tell us more about what actually exists and what the causal relationships between them are, and they tell us what is possible and impossible. In other words, they rule out more. And all of that has, as a kind of byproduct, some of the time, like, for example, in physics and the physical sciences more broadly, it allows sometimes for predictions to be made. Those predictions can be tested against reality. This capacity for our claims about physical reality to be tested itself is embedded as a governing principle into physical reality. But testing is not straightforward or trivial, which is to say that when there is disagreement between an observational test and a theory, we don't just throw out the theory. The test itself could always be flawed. As David Deutsch writes in The Philosophy of Constructor Theory, quote, tests always depend on background knowledge, assumptions about other laws and how measuring instruments work. Popper, 1963. Logically, should any theory fail a test, one always has the option of retaining it by denying one of those assumptions. Indeed, this has been used as a critique of the very idea of testability. For example, Putnam, 1974. But scientific theories are not merely predictions. They are primarily explanations, claims about what is there in the physical world and how it behaves. And the negation of an explanation is not an explanation. So a claim such as there could be an undetected particle carrying off energy is not a scientific theory. Nor is perhaps energy is not conserved. Those are research proposals, not explanations. Consequently, the methodology of science includes the rule that any proposal to modify a background knowledge assumption must itself be a good explanation. End quote.